So I'm going to look at the Chapter 3 review, and this one says make a scatter plot of this data. I've already got the information entered in my calculator. So now I'm going to make a scatter plot of L1 and L2 and hit, make sure I don't have a graph on here, hit zoom 9. There's my scatter plot. This one point's a little interesting to me, so I might hit trace, just double checking that I didn't type the data in wrong. It's 108, 149. That is that point. That's good. So what's the explanatory and the response variable? The explanatory variable is the one that I put down here. It's calories, and the response variable is the sodium. So the explanatory is the calories, and the response is the sodium. Describe the relationship. It looks like I have a strong, positive, linear relationship between calories and sodium. Strong, positive, linear relationship between the two. Are there any outliers? Well, this point seems to be a little different than the rest. Our basic definition is an outlier is a point that lies out. This one appears to lie out. Now it says to find the correlation, so I can do that most easily on my calculator. I don't have to show work for this, I just need to remember I know how to do it. So I'm going to go stat calc, linreg number 8 of L1 and L2, and recall I can store that right here by pressing vars, yvars, function y1, hit calculate, and it gives me r and r squared. If it does not show you r and r squared, remember you can hit mode and go to stat diagnostics and turn them on, or in an older calculator you would need to go to your catalog and turn your diagnostics on. My correlation is r, 0.9195, and the coefficient of determination is r squared, that's 0.8455. Looking back on this question too, are they influential? Influential points are way out on the end of the line. They're on the extremes of the x-axis. So this point is influential, which means that its inclusion or omission is really going to affect the slope of this line right here. So it's a bit of an outlier, but it's definitely an influential point being way out there. Calculate the correlation without that point, so I can just delete that point and find the correlation. What I might choose to do is copy these two lists into another list and then delete the point so I still have the original data, but it's just finding the correlation with that point missing. So as I continue through this, correlation measures strength and direction of linear relationships. So it tells me how strong the relationship is and whether I have a positive or negative association. Number 34, when I change units, the formula handles that. It's basically standardizing my x and y variables. So changing the units does not change the correlation. Correlation could have any values between 1 and -1. But a lot of times we'll say a low correlation is actually 0, because -1 is a pretty strong negative relationship. So R has to be between -1 and 1, but when it's 0 is really when it's the weakest. Correlation only applies to linear relationships in number 36. It is non-resistant because it's based on the mean and the standard deviation. So the correlation is not resistant. Correlation measures strength and direction, but it does not measure cause and effect. Even if it's a strong cause and effect, we need an experiment to measure cause and effect. A great thing to remember is that correlation does not imply causation. The coefficient of determination, as we mentioned before, was about 85, which is 85% of the change in y is explained by the least squared regression line of y on x. 85% of the change in sodium is explained by the least squared regression line of sodium on calories, y on x. sketch a residual plot and explain what to look for. So I'm going to go back to my calculator and I'm going to make a scatter plot of L1 and resid. So go second list, go down to the bottom, you'll see a resid list. Remember, if you haven't done regression, that list isn't there. And now I zoom 9. There's my graph. I'm looking for a pattern or lack of a pattern. I don't really see much pattern. Some people might say that they see a pattern that looks like this a little bit. And I can kind of see that, but what we're looking for is a pattern. At this stage, we don't quibble about whether that pattern is there or not. It'll be obvious to you. Number 41, find the least squared regression line. So I did this when I found correlation, and recall I saved it in my calculator. So here it is. You could also go, if you need to see it again, stat calc number 8. I've already stored it, so I don't have to restore it. And here it is. Y hat is negative 85 plus 3.11x. That means for each time x goes up by 1, I expect y to go up by 3.11. Or for each additional calorie, I expect to see 3.11 milligrams more sodium. On number 43, it says predict it for 155 and 345. So from my home screen, I can go vars, yvars, function y1 of 155 or of 345. Now I think my line does a pretty good job because you'll recall my R was pretty strong. So I think it's going to work well. The problem is this thing right here. 345 is so far outside of this domain. If I go back and look at my X values right here, 345 is way outside of that bound. And so accordingly, I don't really think, I don't know that that line is trustworthy out there. However, for 155, it's right in here. I think my line does well there. So again, I don't like it for the bigger number, 345, because that's extrapolation. Find the residual error for a hot dog with 180 calories. So I plug in 180. Same idea. This is what I predict. 474. That's my prediction, and my residual error is the, sorry, that's not right, is the actual minus the predicted. So the resid is actual minus predicted, or sometimes called y minus y hat, which is something minus 474.15. If I go back over and look at this, it's for 180, I predict 500. So this is going to be 500 minus 474.15, which is 25.85. All right, on number 45, why should we avoid average data? So we avoid that because correlation is basically measuring the noise around a line. So if we went back and looked at what we did before, correlation is measuring how spread out all these points are from the line. Well, when you start averaging things, some of that noise, some of that variability starts to disappear, and the correlation will then appear stronger than it did when I looked at the points individually. Here's another way to look at it. Consider measuring the high temperature and low temperature every day throughout the whole year and graphing them. So on this graph, it's the low of the day, and on this graph, it's the high of the day, and I have lots and lots of points. And it's probably going to look something like this. And I have 365 dots, and the reason it looks like that is because if the low temperature is like 25, the high temperature is probably 45. On the other hand, if the low temperature is 75, the high temperature might be 100, and so it ends up being a positive relationship. If I change this graph, so instead of looking at the high and low each day, I looked at the average high and the average low for each month, so I only had 12 points, the correlation is almost certainly going to be higher on the second graph when I have fewer points that have been averaged from the more points. What is a lurking variable? And I'll explain this in the concept of one we did before with vocabulary size and shoe size. So as your shoe size gets bigger, your vocabulary size tends to get bigger throughout your elementary and intermediate school days because of the lurking variable age. We didn't talk about age, but that's really what's affecting your shoe size and your vocabulary size. In fact, those things are a common response to it. Finally, for number 47, I want to give an example where I explain it each of those ways. So we've heard that an apple a day keeps the dentist away. I'm going to explain that proverb with each of those three cases. If it's a causal relationship, what we're saying is eating an apple causes cleansing of the teeth, which makes it a causal relationship. That's what kept you from getting cavities. A common response explanation would say something like this: healthy people tend to eat more apples, and healthy people tend to have better oral hygiene and fewer cavities. So your lack of cavities and your apple eating are both common responses to your healthy lifestyle. To explain that relationship in a confounding way, I say things like this. You know, the apple probably cleaned your teeth a little bit. Your healthiness probably helps. The fact that you're eating apples means you're not eating Snickers, so that probably helps. The fact that you have apples around your house might mean that your parents are more health conscious, so they have fewer soft drinks around the house, which that helps. They may also be more likely to have flossers, which is going to help your teeth. All those things wrapped up make it a little confusing to figure out what did what. That's what confounding is all about. Number 48 says fill in the marginal distributions. So those are just the distributions in the margin. That's what I've done first on that one. It says what percent of these people smoke. So the percent of people that smoke is going to be 312 out of 825, whatever percent that is. The next one's where things start getting interesting. It says what percent of never smokers. So all I want to focus on right now is the never smokers. So the never smokers are right here. Focused only on those people. What percent complete high school? That's going to be 97 out of the 357. And then looking at it the other way, it says what percent of those with 4 or more years of college? That's these people. Out of that group, which ones have quit smoking? That is 63 out of the 186. What percent of smokers, I guess we'll go with that last column, did not finish high school? 113 out of 312. And one thing you might pick up on number 53 about the relationship between smoking and education, maybe we could focus on this part of it for just a second, and you see that the number of smokers drops steadily and dramatically with the more education that a person has. So the higher the education, the less likely that we'll find a smoker in the group.